All right, look at your notes. Lesson 8.9, graphs of linear inequalities. All right, so far what we've been doing is graphing linear equations. Do you remember the difference between equations and inequalities? Okay, what will you see in an equation? You'll see an equal sign. In an inequality, you're going to see either less than, greater than, less than or equal to, greater than or equal to. Now, an ordered pair is a solution of a linear equality if we substitute those, the x and the y, into that inequality and it makes a true statement. Just like the linear equations. Okay? Now, let me take you back down memory lane a little bit. We started off solving equations. Equations because of the equal sign. So what we would do is isolate the variable and we would find out that x equals 5. Now, we didn't graph that, but if I had asked you to graph that solution, you would put a point on the number 5, correct? Is there any other number that we can substitute for x and make this a true statement? No. Only 5. That's why we have a point on the 5 on the number line. Then we started solving inequalities. We don't have an equal sign anymore. We have one of those 4 symbols. Greater than, less than, greater than or equal to, less than or equal to. So we solved it in the same way. We used the same steps. -2, -2. 2x is greater than 10. X is greater than 5. But what we did is we showed our solution different. Remember, we put a 0 here. We put our 5 on the number line and its opposite. Now, we showed that 5 would not be part of the solution by putting an open circle on 5. Do you remember that? And then we indicated that all of these numbers that are greater than 5 are part of the solution. If I plugged 5 in to this inequality, 2 times 5 is 10 plus 2 would give me 12. 12 is greater than 12. Is that a true statement? Is 12 greater than 12? No. It's equal to, but that's not in my symbol, is it? If I plug 6 in, which is greater than 5, I would get 14 is greater than 12. Is that a true statement? Yeah. So this is how we indicated our solution set isn't just one number, it's an infinite amount of numbers, which is why we have the arrow on our number line, correct? All right, then we started solving linear equations. So now we have an x and a y in our equation. So the first thing we did is we used x-y tables, right? We plugged in any number we wanted as an input for x, and we solved for y. We did that 5 times until we had 5 ordered pairs, and we made the line. Then we used intercepts. And then finally, we used the slope and intercept when it's in this form. So in this linear equation, what's my slope?
2 over 1.
2 over 1. What's my y-intercept?
0, 2.
0, 2. So we plotted our y-intercept, and then we used the slope to plot more points that are going to be on that line. 2, 1, up to right 1. I'm going to reverse so I can carry my line in the other direction. minus 2, left 1. And then I drew a line connecting those points, but we understood that any point on this line would make this true, right? Do you remember when we used the iPad app and I had the point on the line and I just moved it, and as it moved up the line, you saw all the ordered pairs change really fast, right? So this whole line is filled with ordered pairs that if we plugged them into this equation, it would make a true statement, correct? We are going to, today, we're going to learn to solve linear, so it's going to have an x and a y, inequalities. I'm going to show you how we're going to do that. We're going to solve it just like when we were doing equations. We're going to solve it. We're going to go about the steps exactly the same way. So look at example 2 in your notes. Is this in slope-intercept form?
Yes. Yes.
Yeah. This is what we're looking at. I want you to look at this. Now, we're just going to do exactly what we did with linear equations. We pick out the slope. What is my slope here? 2 over 1. And my y-intercept is 0, 4. I'm going to plot my y-intercept at 0, 4, then use the slope to plot more points. 1, 2, 1. I'm going to reverse because I'm running out of my graph. 1, 2, 1, 1, 2, 1, 1, 2, 1. I can do this all day. This is where you're going to need to wait. Look at step number 2. You determine whether it should be a dashed or a solid line. You're going to do that just like we did with the inequalities with the open circle or the closed circle, the filled-in circle. A dashed line is going to be like an open circle. If you have greater than or less than, it'll be a dashed line. If it's greater than or equal to, less than or equal to, it will be a solid line. So in this case, we have greater than or equal to, so I'm going to draw a solid line connecting my dots. We're not finished though, because what this is indicating is that only the points on this line would make this true. But that's not the case, because any of the points greater than these points would also make them true. That happens to be all of these points above the line. I could pick out any point here that's above the line, any point that's on this side of the line, and if I plugged in the x and the y, it would make a true statement. Just to prove it to you, I know you trust me, but just to prove it to you, let's pick a point. -3, 3. All right, so I have -3, 3. I know this is my x, this is my y. So let's go back to the equation. Y is greater than or equal to 2x plus 4. So I substitute 3 for y and -3 for x. 3 is greater than or equal to, this is -6 plus 4. 3 is greater than or equal to -2. Is that correct? Yes, it is. So somehow we have to show that all of these points would also make it true. And the way we're going to show that is by shading. So if it is greater than, we're going to shade above the line. If it would have been less than, we would shade below the line.
So greater than?
Greater than is above the line. Less than is below the line. Now, remember how we've been talking about the line shifting up the y-axis, shifting down the y-axis? If you have trouble seeing which is above and which is below, look at the y-axis. Where are the numbers greater? On this side of the line. So that's the side you would shade. The numbers that are less than would be on this side of the line. So if you were going to shade less than, it would be on this side. This is your solution. And what this tells me is that the points on the line and the points on this side of the line, above the line, all could be substituted for x and y and make this a true statement.
So, when we determine whether you should shade above or below, you just choose a random pair?
No, you look at the symbol that's in the inequality. This says greater than or equal to, so you shade above. Greater than is above, less than is below. You might want to write that in your notes. Greater than is above the line, less than is below the line. So greater than above, less than below. Okay? Jay?
It already said in the last shade above the line for
Perfect. Let's do more examples and see if it doesn't clear up a little bit more.